All right, let's solve some more stuff. Okay, so here is another one, and we're just going to solve this quadratic. Remember, when we're solving a quadratic, we're looking for the zeros. We're looking for where it crosses the x-axis, the solutions, the intercepts, all of those words mean the solutions to a quadratic. Okay, so let's take a look at this, and there's something different about this one than the other ones. Do you see how it's not set equal to 0? So that's important because quadratics have to be set equal to 0 for us to solve them, okay? So if this one's not equal to 0, we need to make it equal to 0. So we need to get everything on one side so that we just have something equals 0, okay? So we're going to subtract 3x from both sides, and that's going to give us 3x squared minus 3x minus 60 equals 0. Okay, and then I see a greatest common factor, so let's just pull that out here first. Okay, and then we look at this, and we the first question I always ask is, can I factor it or can I solve it with a square root? Because if not, I got to do the quadratic formula, and it's not terrible, it's just tedious. So is there something that multiplies to negative 20 but adds to negative 1? I believe so. Negative 5 and 4. Those multiply to negative 20 and add to negative 1. So we can just factor this. So this is x minus 5, x plus 4 equals 0. Now remember, when we're solving, this is not done yet because we're solving this. We're trying to find for what x values does this equation equal 0, right? At what x points, at what points does this equation cross the x-axis, which is what x equals 0? So we look at this and we say, okay, for this to equal 0, either this factor has to equal 0 or this factor has to equal 0, right? Because if this factor equals 0, the whole thing becomes 0. If this factor equals 0, also the whole thing becomes 0. So we say x minus 5 equals 0, or x plus 4 equals 0. Therefore, x equals 5 is one solution, and x equals negative 4 is another solution. So the two solutions to this quadratic are x equals 5 and x equals negative 4. That's where it crosses the x-axis. That was a lot easier than the quadratic formula because it factored, right? Okay, here's one that we're going to solve with square roots. The reason I know we're going to solve it with square roots is because I look and I see I don't have any x's, I don't have like x squared plus 3x or anything like that, right? I just have some x's, this is vertex form, but I have some x's that are under a square root, or not a square root, that are inside of a squared right now, and then I have numbers outside. So it just, you just get used to seeing that, right? So you'll get used to looking and seeing, take this off, I keep catching it. You'll get used to seeing things that are, and say, oh, that looks like I could solve it with a square root. So, to solve this one but with a square root, I need to get x by itself. How do I get x by itself? Well, let's start by adding 9 to both sides. And I have x plus 5 squared equals 9. So now I want x by itself, so I'm going to take the square root of both sides so I can get x all alone. So now I have x plus 5 is on this side. And the square root of 9 is plus or minus 3. Because remember, it could be positive 3 or it could be negative 3. Both of those values squared equal 9. So now, here's the tricky part. Now I have this and I have to figure out what do I do with it now. Well, just remember that plus or minus means either x plus 5 equals 3 or x plus 5 equals negative 3. So then I just solve them. I subtract 5 from both sides and I get negative 2 there, and I subtract 5 from both sides and I get negative 8 there. So these are my two solutions. That's where it crosses the x-axis. Okay, here's another one. Now this one looks a little tricky because it's got x's on both sides. Now remember, to solve a quadratic, we're finding the zeros. We're finding where it's equal to 0. So we need it to equal 0, so we need to subtract things so that everything is on one side and 0 is on the other. So let's go ahead and subtract 3x and add 10. to both sides. Now that zeroes that out and that zeroes that out. So we have x squared plus 9x minus 3x plus 10 minus 1 equals 0. We have x squared plus 6x plus 9 equals 0. And then we look for factors. Is there anything that multiplies to 9 and adds to 6? I believe there is. 3 and 3. So I have x plus 3 times x plus 3 equals 0. Okay, so now remember, that means either this is equal to 0 or this is equal to 0. Well, guess what? They're both equal to 0 at the same place, right? X plus 3 equals 0, therefore x equals negative 3. So this one crosses the x-axis at negative 3, and that's the only place it crosses. That means this is one of those ones where the vertex sits right on the x-axis. All right, let's look at a few more. We'll get to this one. Okay, so this one's already equal to 0. So don't have to do any extra algebra. We just have to look at it and say, okay, is there anything that multiplies to 10 and adds to negative 3? Let's see. Multiplies to negative 10 and adds to negative 3. I think that would be 5, negative 5 and 2. So x minus 5 and x plus 2 equals 0. So these are the same equation, just written in different forms, right? So then either x minus 5 equals 0 or x plus 2 equals 0. So x equals 5 or x equals negative 2. Those are our solutions. That's where it crosses the x-axis. All right, let's look at this one. Now this one again, I would look at it and think, ooh, that's a good candidate for square root because it has this little, x minus 2 inside of the square. So I can think, ooh, I could get everything on the other side and then take the square root. So let's do that. So I'm going to subtract 64 from both sides. And I get 2 times x minus 2 squared equals negative 64. And then I divide both sides by 2. And I get x minus 2 squared equals negative 32. Take the square root of both sides to get x by itself. And I have x minus 2 equals the square root of negative 32. And now I'm stuck because I don't know how to take the square root of a negative. Or do I? Square root of a negative, this is the same as the square root of negative 1 times the square root of negative 32, or a positive 32. So now I have x minus 2 equals I root 32, because remember, the square root of negative 1 is I. Now, let's simplify square root of 32. It can be divided by, it can be divided by 16. So we're just going to rewrite this as 16 times 2. And so then I have x minus 2 equals I times the square root of 16 times the square root of 2. So I'm just rewriting it and simplifying as I go. So the square root of 16 is 4. And then I remember that I can't write it that way. I need the 4 in front of the I. The real number has to be before the I. So I have that. And now, uh-oh, I forgot my plus or minus. That should be plus or minus 4. So plus or minus 4. And the reason that I remembered that is because I thought, well, this has to have 2 solutions, right? So now I'm going to add 2 to both sides. And I'm going to end up with x equals 2 plus or minus 4i root 2. And that's my solution. So this one is one of those ones that has imaginary roots, which means it doesn't ever cross the x-axis at all. It actually is like either above or below. And in this case, it's facing up, I believe. Yeah, so it's facing up because of that 2. So it's actually above the x-axis. Okay. Now let's solve this one. Go ahead and erase some of my work there so I can get a nice big clean spot for you. Okay, 4x plus 7x equals 11. Again, we want everything to be on one side because we need it to equal 0, right? We're trying to figure out where it equals 0. So we have 4x squared plus 7x minus 11 equals 0. So see if I can clean that up a little bit. There you go. All right. So is there anything that multiplies to negative 44 and adds to 7? Not off the top of my head. So I think I'm just going to do the quadratic formula because I'm not finding anything that really makes me think that, yeah, it's cool, let's factor, right? So if it's not super obvious, you can use the quadratic formula for something that factors. It's totally fine. But factoring is just faster. So if you look at it and you just can't think of anything that factors, then just use the quadratic formula. All right, so let's see, I'll do another color for you. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so that's negative 7 plus or minus 49 minus 4 times 11 is 176. So it's plus 176 because I have a negative 11 times a negative 4. And then all over 2a. And 176 plus 49 is 225. Negative 7 plus or minus the square root of 225 over 8. Oh, the 225 does have a square root. Square root of 225 is 15. So we can just keep going with that. So negative 7 plus or minus 15 over 8. And so that means either negative 7 plus 15 over 8 is a solution, or negative 7 minus 15 over 8 is a solution. So then I just solve both of those. And I have positive 8 over 8. And negative 22 over 8. So x equals 1, or 22 goes down to 11 over 4. Or x equals negative 11 fourths. So since I came out with really nice numbers like that, that tells me that this probably did factor. In fact, it would factor into let's see, what multiplies to a negative 44 but adds to 7? Four and 11. 4 and 11, the numbers in our problem, they're right in front of our faces. We didn't even see them. You probably saw them. I didn't see them. So you could have used 4 and 11 and factored. But you would have had to use bottoms up or slide and divide. So this is good enough too. This gives us an answer every time. So when you're stressed out on the test, or when you're stressed out and you just don't know, just use the quadratic formula, and then, factoring is just quicker. Okay, so we'll do another video here soon on the next page.